their performance and their throughput sixfold. So we cut the number of servers that they need to 1/3, double the throughput, and halve the latency of their application. So what were the major takeaways? Well, while we were doing that engage, and myself and my colleague David, we actually said, we received this very nice question, which I don't know if you ever had this question or you asked yourself this question, is that, oh, well, in order to improve your performance, the throughput of your application, you have to disable logging. Well, we need logging, right? So why is this happening? Why we are getting there? So the typical reason for why we add a lot of logs in our application is there is a bug. And you get called at Sunday morning, 7 a.m., everything is down. And, whoa, what's happening? Oh, I don't know, somebody put some crazy input in your publishing system or in a product or whatever. And now it's not working anymore, it's crashed. And you go down there in Sunday morning and fix the things. And to understand what's going on, typically you might want to add some logs, okay? And conventional wisdom says that more you log, the better. So we keep adding logs to our own application, quite for a bit of time. And most people think all of this is harmless, okay? The typical time thought about how much time we spend logging a line is 0. Okay, absolute 0. Oh, well, it's just a log line. How much will it cost? Cost nothing, okay? Yeah, might not be. Pick a number. But there are some decimals out that 0, okay? An engineer can say, well, 0 is 0.22, whatever. Whatever number you can pick, okay? This number is completely made up, or more or less. It came from some other things. It's not related to Mr. Porter, Net-a-Porter. So let's take this number, and if to log a line, it takes 0.22 milliseconds, and we want to do 2,000 requests per second, it means we are spending 440 milliseconds just for logging. Wait a second, we want to do 2,000 requests per second, okay? So it means that we have 660 remaining CPU time for doing our business logic. Okay, just for logging one single line, I received this request. By the way, this is clearly important because one of the things that Node.js does is it's single-threaded, and you run one instance of Node for your very little VM. So what it means is we are literally constrained by the fact of these 660 milliseconds remaining. However, what it happens, we said the more you log, the better, right? So what it says is if you're actually running 10 log lines per second, per request, in fact, we are spending 4 seconds to log to boot out the logs for 2,000 requests per second. So, oops, nope, that doesn't compute. We can't do that, okay? Logging becomes our major bottleneck for our application. So logging lines, in fact, matters. So the moment you start logging, it matters for performance quite a lot, in fact. And this is a typical kaboom effect, because what it happens is, yeah, we can do that, okay? We are stuck. And what you might want to ask yourself, why all of this, why our code is so slow, okay? Why logging should be so slow. And we start wondering and thinking and, making some experimentation. And, oh, I don't have that. Do we have a piece of paper? I do have, don't worry. I do have. Just give me a second. The fantastic program, okay? So, you have a piece of paper, okay? The typical thing is that when you have a log line, okay, this is your log line. We have folded it. Then you have an adapter, because when you create a logger, there's a factory that creates your logger, okay? Then you have, oh, wait a second. I have multiple transport because I need to send those logs to Elasticsearch, Kibana, or wherever I want to go. OK? Wait. I still have my log line. I still have my data that I want to put down to emit as a log line. It's still not ready to be written down. I need to serialize that data in a format that some machine later on should read it. So I compress it. I change the format. And well, I still haven't written anything. So I am doing it again. Turns out that there are so many times that I can fold a piece of paper. OK, I don't know if you have seen the video. And this is a very nice video that you can fold a piece of paper only about 7 times. And the problem is all this work that I just done to destroy the program of this conference. Turns out that that's what happened most of the time when you do a log line, when you log a line. In a lot of platforms, there are factories that create that. There are wrappers of wrappers of wrappers of wrappers of wrappers that prevent your application to reach its full potential, just because you are creating a factory of a factory of a factory, multiple things, and stuff like that. So this is one of the problems where we are losing a lot of performance. So I had, myself and my colleague David, we had an idea. And we have this serendipitous moment. Let's write a fast logger, OK? They asked us, maybe what should we use? Because we said, well, this is the problem, OK? Yeah, but what do you recommend? Our customer asked, well, what do you recommend? Oh, nothing really. I don't know. This is nothing fast. Whatever. You are already using our best recommendation, right? So we can't really improve on that. So let's write a fast logger. So we wrote Pino. And by the way, I have stickers. So Pino stickers, if you want them. So I wrote Pino. Nice logo, right? So we log in line delimited JSON. I don't know if you know what line delimited JSON is. It's whenever you log, so log lines are built for machines, OK? You want to read that log line and then process it, search it, do something out of it later on. So with the new line delimited JSON, you put a JSON, and then a new line, and then a JSON and a new line. And every line and every log line is just a simple JSON document. So you can attach properties and whatever just to that message. Why we are using JSON? Because it's very easy to process afterwards. We could have used XML, right? But probably not nice. We could have used CVS. Yep, not nice as well. To parse, JSON is just about right. We could log in binary. Absolutely. Will that be faster? Yes. Will that be human readable? Probably no. So, there are balances. How do we parse? That? We parse it using this in Node. We can parse it using something very simple. We use something to split our log line, split standard input, for example, along new lines, and then we get some objects out of it, and we can do stuff on this. So it's very easy to parse 2 lines. We can parse it format and move on. So Pino, we wrote Pino based on Bunyan. Bunyan, it's another very popular logger, and it's very cool. Apart that's slow, but that's another story. So that was our best recommendation, actually. So we write Pino because we were Bunyan users. So we said, well, we want Bunyan. So, yep. So this is Pino, very easy. You require it. I don't know if you're familiar with Node, but I hope so. So you require it. You require your, we require Pino. And you see, we instantiate it, and we have our Pino object, and then we call info, and it's normal. We can also pass down any number of, we can also pass down random objects in it. All those properties will be put down in our new line delimited JSON log line. So with Pino, we have benchmarked Pino to do 10,000, to emit 10,000 log lines in 250 milliseconds. Again, is this fast? Not, depends. Let's run some maths. So our 2,000 requests per second that we said before, we got some time left for our business logic. So it's good. we are getting 950 milliseconds remaining to reach our target. If you want to log 10 lines for every request, then we can still have half a second left for our business logic. Wait a second. Oh, now this is feasible. Before, if it was not feasible. Okay, if your logging a line takes a lot of time. In fact, if you want to log a lot, you're going to slow yourself down, and it becomes the main bottleneck of your application. We can also go faster, way faster, with extreme mode. Wow, why do you put in an extreme mode in? Well, because there is an endless limit to the. You can start improving the performance of your application endlessly. Okay, so you can keep adding and improving it up until you reach a point of no return. So we went down the rabbit hole and also implement extreme mode. It's a trade-off. So with extreme mode, you can more than halve again the number of the time it takes to log 10,000 log lines, and we can improve the performance twofold. What's the trade-off? Well, let's see. Well, if we log 10 lines with extreme mode, now we have 200 milliseconds left for 10 log lines. If we log 10 log lines, we have improved again our odds and reduced our performance and reduced the overhead related to logging. The trade-off of extreme mode is 4 kilobyte batching. So Pino tends to emit a log line as fast as it can. So it passes the data out to the operating system as soon as possible. With extreme mode, in fact, instead it uses 4 kilobyte batching. So we batch for 4 kilobytes. We have a buffer of 4 kilobytes, and we write that stuff to that buffer before sending it out. In fact, it's not 4 kilobytes. It's a string of length 4,000, which I don't know how much you are familiar with this, but it's there is UTF-8 and stuff like that can influence it badly. So in order to use extreme mode, you just pass extreme through. Hey, easy. So as part of this, we also started working on, well, the second question we got when we started working on Pino was, yeah, but this is, how do we integrate this with our servers, okay? Because we have found out that some of the problem when we were using a logger, in fact, were not the logger itself, but was how this logger was integrated with the framework. So if you're using Express in Node, how many of you use Node? Some of you, fantastic. If you're using Express, probably a lot of you have used Express or have known about Express, right? So you can use Express with Pino with Express very easily. You instantiate Express, and you pass Pino Express, Pino logger. Hey, easy. And you use it as every other middleware in Express, and you just get this nice request.log. One of the nice things that we do for every request for the logger that we have written, every single request has a unique ID, and that ID will be merged automatically on every of your log line. We'll see what that means in a second, but it means that you can track you can track all the log lines for a single specific request in your major stream of asynchronous stuff. So it's very handy, okay? So we have Express, and we have Hapi. How many of you have used Hapi? No one. Great. So Hapi, it's a new framework written by Aaron Hammer when he was at Walmart. And this is the Hapi 17 thing, the new version of it. It's you create Hapi, you create a server with Hapi, and then you register the Hapi plugin, an Hapi plugin. Hapi 17 used the new async await syntax in JavaScript, so just run only on Node 8. And you can also pass a pretty print. Whenever you pass an option to Pino, you can also pass a pretty print true, which means that it will automatically, instead of spitting out JSON, because it might not be superhuman readable if you're for development purposes, you might want to enable pretty print, which means it will actually format your line in a very nice way, rather than using emitting JSON, because you might not be able to read JSON so well. And then we start our server, and in our route, you can still have request.log or request logger info as before. Okay. So very easy to use. It also works with Restify as much. It's probably the same as Express. Restify is one of the earliest framework compared to, they were born more or less at the same time of Express. Didn't win, Express win, but we support this as well. And we also support Koa. Koa is another framework built on top of async await. So it's pretty cool. And of course, you can use Pino HTTP if you are using HTTP create server. Okay? You probably shouldn't do that, and you should use one of the nice frameworks that are available. But if you want to get the best performance out of things, just use require HTTP. That's the fastest thing you can use. So yeah, well, we wrote this logger, and the biggest challenge is to try to, one of the challenges is how to communicate why this thing is fast, and how we can improve, and how we did improve. We fixed some of the performance problems that plagued the other frameworks, and what were our design choices. So the first secret sauce was avoiding JSON.stringify. How many of you have used JSON.stringify? Everybody, like, I hope everybody. If you're not, you're probably still using XML. So I hope you're using it, okay? So JSON.stringify. JSON.stringify, it's, you see, the reason why it's slow, it's because JSON, it's a recursive data structure. So you have an object, but then you have a recursive algorithm to traverse that big of an object, all the layers, and concatenate them all together. Now, the other problem, the other bit, it's some of the stuff that we put in all of those log lines, it's always the same. So we put the PID of the process, the host of the process, okay, and stuff like that. So what we did, we started concatenating strings, at least for the common parts, and we saw a great improvement in performance. Another thing that we did was we used date.now instead of new date to ISO string. So you might be using new date dot the ISO format. So when you have a number, when you have a date in whatever language you want, and you want to send it over as JSON, you convert this into ISO whatever format, calling dot to ISO strings, which is called this big long string typically UTC time, in the UTC time zone that univocally represent that point in time. However, we have another way of representing this, which is the Unix epoch. And as far as I know, generating the Unix epoch is an order of magnitude faster than calling to ISO string. So, well, ISO string, it was nice, but goodbye. We are logging with putting down epoch time. And here come the magic. So what we have been doing is we have been concatenating strings, and we are using to ISO string instead of new date instead of instead of twice a string. Now we have this big blob of things that we have been concatenating, okay, one after the other. And you see, one of the key points in JavaScript is JavaScript. The way strings are represented in JavaScript is different compared to a lot of other languages you have been using. First of all, strings in JavaScript are completely immutable. Okay, you can't edit a JavaScript string. You can't replace a character in that string. It's fully mutable. Another point is if you concatenate two strings in a lot of languages, mostly Java and C# and whatever else, what it does, it allocates a full new string, which is it has to take the full copy of the 2 bits. Okay, so concatenating strings, in fact, is a costly operation. In JavaScript, this is not true. What it does, at least what V8 does, it represents the strings as a tree. So if you want to concatenate A with B, in fact, it allocates another element at the top. Okay, and it says, you know, these new strings is the result of the concatenation of A and B. And then you can go on and on and on and on and on and on and on forever. However, there is a very special command that you can use in V8. So Node itself, it's based on top of the V8 engine from Google. It's the same thing you use in Chrome. And in Node, you can say node -- allow -natives. And this command enables us some other special commands that you can start with an ampersand. And you can say flatten strings. And flatten string take whatever string you're passed in, and it transforms this big tree in a C-like string. So it basically does all the copying and resolves completely the full tree. Now, this is not easy to use because it has this ampersand sign and it to run Node with a flag. So we wrote this nice little module called flat-str. And what it was, this flat-str actually converts the strings, okay? How does it work? It passes the string through the number constructor. Passing a string through the number constructor in Node convert that string to a single, to resolve fully the tree, which is the big string. Now, why this matters? It is why it matters. So you have this, when you want to write a log line, okay, or anything to a socket, you have, you need to do 2 things, okay? So you have said, well, write this string down there. But in reality, you need to query the length of the string in bytes, okay? Not UTF-8. Okay, if you do the string.length property, that returns the characters. But you want the number of UTF-8 bytes of that string. So these 2 can be different. And then you need to allocate this buffer of memory, and then tell V8, hey, V8, take these strings and write it down to that C-like buffer. What it happens is currently V8 is traversing the full tree twice. So once to compute the length in UTF-8, and another one to actually write it to convert it. So if you are concatenating too many strings at the same time, like you are doing, for example, when you are rendering an HTML template or whatever else, you're actually paying this price. So passing this through this function, either it's a no-hop, or it's because the number construction is super fast, or it actually improves the performance when you are writing that string to a socket. Another thing that we did was called fast-safe-stringify. And you can, one of the key points of a logger, which is a very important property of any logger you might want to use, is that when you call log.info, what it does, you need to, it can't throw. So your logger must not throw. If your logger throw, we have failed. because logging should be as transparent as possible. So if logging, so you're logging an error, okay? Let's say they're logging an error. If logging that error caused the process to crash, you haven't logged that error, so means you can't do your job. So we need to take that very seriously. So we pass it through this. We need to make sure that we can log that thing. Now, as you have seen our input, we accept unstructured JavaScript objects. So you can add as complex objects as you want to our log lines. However, JSON has this nice property. You can have recursion. So you can create a cycle. Okay, and if you try to JSON.stringify an object with a cycle, it will throw a big error on you. Because it says, well, no, you can't, because it has a cycle. I don't know how to put on a string to render a cycle as a string. JSON doesn't offer any facility for me to represent that. So fast-safe-stringify, or safe-stringify, whatever, transforms any random JSON, make sure that the JSON operation is safe, and it decircles it. So it removes circular loops. Now, in order to do that, we do a very nifty technique. So you see this circle object. So we traverse your data structure that you pass in, and we replace some, and we detect when there is a loop, okay, inside the structure, and we replace this with this circle object. And that circle object, when it has in our prototype, it has a toJSON function, which once called, it will render circular and replace itself. Because when you are using JSON.stringify on an object, you actually have to, it actually go and call the toJSON function on every object is passed on. Another thing that we did is we wrote this library called quick format, which is mostly used to work around a performance bug in Node 4, Node 6, if I remember correctly. So there was a performance problem on Node 4 and 6. And if you use, for example, the %d or %s in your log line, those will be very slow. So with quick format, we could solve that problem. But it's already Node 9, so it's not super needed. So how did we work to use all of these things and how to make our code fast? Well, we used what are our tools of the trade? So the first tool of the trade are flamegraphs. How many of you know what a flamegraph is? One person. Fantastic. So I'm going to show you a little quick video of, let me do this. Yeah, maybe you can see it better. OK. So this is, I'm doing a video of 0x. And with 0x, we launch 0x, and we say profiling. And then we run autocannon HTTP 1.1 load tester. And after we have finished our load test, we hit Ctrl-C, and we render a flame graph. And this is a flame graph. What is a flame graph? In this flame graph, you can see there are flames, and the top of the flames, and in those flames, you can see where it's darker, if that thing has been hit more to some extent than other things, the other part of your code. So it helps out in identifying straight away where your code is spending a lot of your when your application is spending a lot of time. And in fact, it enables also you to filter and remove the core part of your application to identify what if the problem is in Node core, probably not hard, not easy to fix, or it is on other part of your code. So, for example, your code, or a code of your dependency, or maybe even in C++. Okay, you have a C++ dependency, and it's actually spending time in there. So this is an example of one of the very, very early pull requests. Okay, and from here, this is where we found out that JSON.stringify was the bottleneck. So what we did was we set up a demo server. We hit with autocannon, and then we said, oh, hey, well, you know, JSON.stringify is the bottleneck. And then we started manually creating the strings. So this is before. So you see, this is JSON.stringify, okay? And you probably can see it very well on the screen. Maybe on that screen over there, on this one, nope. You see that this is 33% of the time on the stack, okay? And it's like you're spending a huge amount of time just running this function. However, that function is completely disappeared after we have started concatenating strings completely, okay? So we have improved our output significantly just by saying, well, this is the bottleneck. So hey, now the second bit is this diagram tells also us what the next bottleneck that we have found, twice a string. Okay, so we went down and fixed that. So I already demoed autocannon. Autocannon is an HTTP load tester. And it has a very trivial cross-platform installation. That's probably its best feature. So you can use it on whatever platform you are on. npm install autocannon. It's all written in Node. So it's and you can script it with JavaScript. So it's very easy to use, and it can. It's very easy to use, very easy to script in JavaScript, so you can create scenarios and those type of things. It's also very fast, so given that it's a HTTP 1.1 load tester, you can use a feature called HTTP pipelining, which enables you to put more than one request in parallel for each connection socket that you are using. So with this, a lot of the load tester does not support these features. So hey, we can generate more load. So our combo, it's 0x plus autocannon, enables you to improve the performance of your web applications. So there is more to Pino, okay? Because I started talking about transports and sending logs somewhere, and right about now, I just talked about, we split JSON to standard output, okay? Because Pino is more than a module. Pino is a way of life, okay? And the philosophy behind Pino is to provide absolute minimum overhead. I haven't talked about transports and destinations because there are no transport and destinations. Pino writes things either to a file, or to standard output. For two main reasons. The first one, it's a lot of Node applications right now are either deployed within Docker containers, okay, or as part of very, very tiny servers, like one CPU servers that we spin on the cloud. So in both those cases, the logging facilities are very crude. I don't SSH into my box and look into the log files, and I want to rotate them and so on. All my Docker containers are completely ephemeral by design. So if I don't log to standard output and they get collected by the Docker log system and shipped somewhere else, it's not going to work. Okay, I will lose my logs. And on servers, in fact, I am in those ephemeral servers on the cloud that are spin on demand, typically on autoscaling groups. Again, I don't SSH into the box and get into the look at my log files. So nope, not needed. So Pino has no overhead. But how do we ship logs then? Okay. Well, first of all, if you are rotating your logs from your code, stop doing it. Okay. In whatever language you're using, even if you're not using Node all the time. A lot of these libraries provide facilities to rotate the logs. You've probably seen this in Java, C#, .NET, Ruby, PHP, whatever. Rotate your logs yourself. How do you rotate logs? There is in your Unix, in your Linux box that you are deploying into, there is a little nice tool called log rotate. How many of you have heard about log rotate? Yay, perfect. So why the hell? This guy is written and built to rotate logs. Use this guy, okay? It's way better and more performant to use that guy than to rotate your logs in your application. Why does this happen? Because of this. Rotating the logs. So if I need to rotate the logs inside my application, every time or from time to time, while I'm running my application, I am checking, is this file too big? Should I rotate? Is this file too big? Should I rotate? Is this file too big? Should I rotate? So I'm spending time and introducing another layer. More specifically, I'm scheduling a possible I/O operation. And because I'm scheduling an I/O operation, that will take time. So, yep. So what we do is we also offer the pretty print mode. You can pass pretty print, or you can use the Pino command line tool. So you can pipe your logs to Pino, and Pino will emit a little bit of something better, more human readable instead of JSON. I can read JSON like the metrics, but it's not nice, okay? I'm not super happy about it. Or you can use Pino Colada, which is another module written by a friend of mine, Ira. And you can use Pino Colada, and Pino Colada emits emoji, okay? We like emojis, right? So you can have an emoji-powered log system. Hey, how about that? Cool. So the Pino philosophy is, if you want to ship your log somewhere, run this as a separate process, okay? Don't run it on your main one. So right about now is the moment where I run my demo. So I hope the demo gods are with me. Demo gods are always a little bit scary if you're doing talks. So I'm going to use Docker. So I'm going to demo Elasticsearch integration. How many of you know about Elasticsearch? Probably everybody at this point. So there is Elasticsearch is this nice system where you can put your logs in. Well, a lot of other things, it's a database really. But you can put logs in, and it has this nice thing called Kibana that you can build nice dashboard on top. So now I'm spinning up Elasticsearch and Kibana using Docker Compose. Hey, I'm cheating, okay? I'm boosting them up Docker with Docker so that I can start from scratch every time I do this talk. So after this, we run. So and then I have my server. My server is just an HTTP server, which we use Pino HTTP on, and we just log the request and the response. Very easy. Now, we can do node Pino server, and then we pipe this to Pino Elasticsearch. Now, Pino Elasticsearch has a huge lot of options in it, okay? It's configured to look for Elasticsearch on your operating system, which my Docker Compose is set up for doing. So I just hit run, and this works. So now I just need to go to open a page, and you see at the top of that hello word, okay? Hey, this is my server. So I created a log line, okay? So this should have created something on my Kibana. This is Kibana, freshly built. Let me zoom in because you probably don't see a thing. So this is, yes, this is Kibana, freshly built. You see configure an index pattern because it knows nothing about the data you have been putting on. So you need to name this. By default, Pino put stuff in the Pino index. And as much as the moment you put Pino in there, it automatically recognizes that there is a time field. Hey, it recognized my thing. And it actually recognized epoch straight away. So, and I hit create, and it create me this nice index. And hey, there's a bunch of things in there. And then I hit discover, and I can see my log line. Hey, I have 2 log lines because I refreshed my page. Hey. So, and we can see here that there is an ID index core. This is from Elasticsearch. Then I have host name. This is my laptop. The level 30. The message. The PID of my process. Some headers, cookies, remote stuff. Hey, it's using IPv6. Hey, nice. Some headers, the response header, and this is the request ID I was talking about. Okay, so you can search for that specific request ID. Well, you know, these we haven't done anything. Okay, This is basic Kibana stuff. So we can actually add we can actually create some load to Kibana on our servers. We are running autocannon for 5 seconds. And we have created a bunch of log lines in there. Now this is lower because I'm running Elasticsearch, Kibana, Node, and Pino Elasticsearch on top of doing the VGA card, using the HDMI output. You might not know, but plugging in an HDMI cable on your laptop actually decreases the performance of a laptop of 20%, at least. Why I've measured that, don't ask. But I did that. So now when we go here and here, we can refresh. And after we have refreshed, well, we see still a thing, but now it has 41,941 log lines. So we can zoom in and zoom in maybe a little bit more. So, and we can debug our stuff. And we can track, for example, this log line here was, it has 41,337, whatever the ID, blah, blah, blah. OK? So it's very easy to use. And there are a bunch of other integrations. Also, Pino Elasticsearch, you can use it to feed log lines to AWS. So Pino has a nice ecosystem of things around it. A lot of modules. So it's Pino T, Pino syslog, Pino socket, and even there are 2 frameworks built on top of it. Okay. Oh, this Pino multi-streams is nice because if you really want to do the multi-stream stuff, sending log to multiple installation, it can do that. So Pino had a fantastic, nice ecosystem impact, which means that in 2016 with Node 6, this was how the performance of the various loggers look like. So this was Winston. I'm not putting absolute numbers in this. The scale is relative. So this is 2016 with Node 6. Then you see that Banyan got faster, and debug got faster. Pino still faster. But with Node 8+2, we got an extreme amount of improvement. Why? Because from Node 8+2, and you really use Node a Node version latest than 8+2, there's a new optimizing compiler from V8 called Turbofan that can dramatically improve the performance of your application straight up to the box. So hey, pretty good. So after this, I want to, I started working in Pino in 2016, and then I went through and said, well, what's the next big overhead that I can fix in my application? And I said, well, I started benchmarking HTTP, basic HTTP, and then I checked Express, and I said, well, where did this go? Where did all this performance go? And I wrote some very nice flamegraphs. So this is the first flame graph. This is the bare one, and then this is Express. And you can see the difference straight away looking at the picture, that this is what Express is doing. Okay? It's very big. So I started writing my own web framework. And called Fastify. And Fastify is way better, way more performant than Express. And more or less, it compares very well with both Express and Hapi. Okay, it was inspired by both of them. How do you use? Wait a second, wait it is. I lost a slide. Okay, I lost a slide. What it does is, and this is Fastify, okay? Oh, this is a slide. This is how you use Fastify. So you create Fastify, and you specify your route and reply send, and so on. Very simple to use. And this is the flame graph. As you can see, this is very similar to the bare one. It has very little overhead. So we are right about in time. So Fastify works by pre-initializing some fast data structures beforehand, so it can serve your request very quickly. We actually, in fact, improved, made the technique that we have used in Pino generically available, and it's called fast JSON.stringify, which helps improving the general performance of your JSON.stringify function just by concatenating a lot of strings. How do we do that? You feed in the schema of the data that we want to use. So fast JSON.stringify is based on the schema, and it generates some random code using new function. Hey, pretty cool, right? And this is how you use it. You pass the schema, you specify the property, and then you render it. And it's faster, OK? It's slightly but faster than JSON.stringify Node Core. So yeah, I'm going to skip this slide because I'm a little bit late. We have a very fast routing algorithm, and it's called Find My Way. Fastify, of course, is built on top of Pino. You just enable Pino passing logger through, and that's enabled. And yeah, this was Fastify. This is the thing that I'm working on right now. So right about closing this presentation, it's available this URL, so you can get and see it. It's based on HTML5. There's also some code also for the source. I would recommend you, if you are interested to know, there is a Node cookbook with myself and my colleague David and myself. I wrote the performance chapter on this, so you can check it out. And this is me. I am Matteo. I am a principal architect at Nearform. I mainly work on Node Core. So I'm part of the technical steering committee. So if you have any questions about Node and whatever problem you have, or if you want to chat about how to improve, to use Node in your thing, ask me. And as I said, I work for Nearform. We are a JavaScript company at about 120 people scattered throughout the globe. And we are adding JavaScript developers. So if you want, hey, come on board. So thank you, folks.